So I'm Jurgo Preden. I am actually a native Estonian, which is why I'm speaking at this event today also, but currently in California. And why I'm here, I'm going to tell you during my talk. And what I'm going to talk about is smart dust in smart environments, which has been my passion for the past 15 years. The world will be going with Smartdust in the future. First, I'm going to start from a bit further away in time and talk about fantasies and dreams. When I was a little boy, I used to have a very lively imagination, and I would fantasize about different things and also build different gadgets. For example, land vehicles with sails and things like that. When I got a bit older, then I started to fantasize about motorized vehicles and how these could operate. And I would say that Smartdust and what we're doing with Smartdust is like a fantasy being realized in the real world, in the physical world. Because say 15, 20 years ago, the things we're doing today was only the stuff of fantasies or the stuff of dreams, would not have been real. So a few words about my background. So after I grew a bit up, then I attended Tallinn University of Technology. This picture should be familiar. So that's where I got all my degrees, and that's where I'm also doing my research. I was an engineer. My first engineering job was in Silicon Valley almost 20 years ago now. So got an experience in the real world quite early on. I was at Microsoft Research 11 years ago in the Invisible Computing Group. So that was already with computers in the environment, invisible to us, working with us and for us. 11 years ago, I also started the company Defendec, which has deployed its border patrol solutions in 20 countries. So I was the CTO of Defendec. I led the development of that product. I was a Fulbright visiting scholar in the US in the Multi-Source Information Fusion Lab in New York, Buffalo. When someone tells you that Buffalo is a snowy place, then this is not the case. This is Buffalo in January, so as you can see, no snow whatsoever. I'm also been a Estonian representative for some NATO research activities. And now what I'm doing is ThinAct. So in ThinAct, what we're doing is we're bringing the research ideas that me and my group have been working on for over a decade into the physical world, into the real life. So into offices, into manufacturing halls, and into the cities. The light you see there is actually a street light from Tallinn Old City. So when you go later today into the Tallinn Old Town, then you see the street lights. So every one of these street lights contains a piece of our technology. So they're all connected, they're all manageable. The talk is about Smartdust and how this will change our world. So a few words about Smartdust and what it is. Smartdust are tiny computers which are autonomous, which have sensors, so they are able to understand what's going on in the world, and they're able to communicate using wireless communications, and they're also self-powered. So they are full-fledged computers that can talk to each other and that can sense the world. So putting a bunch of these together, you can do very many interesting things. And already in 2003, you were able to cram all of that functionality into a few cubic millimeters. So this is the state of the technology. So you can really have dust-sized computers in the environment that talk to each other and are able to sense the environment. And people have used these computers in different applications. Of course, the first one was military, getting intelligence from behind enemy lines, improving the knowledge of our troops. But nowadays, this technology has also moved into streetlights, as I already explained, into the cities, into manufacturing facilities, into smart offices, and so on. So again, a technology that started in the military that has been deployed in different fields, also in the civilian world. And analysts predict that by 2020, we're going to have 75 billion of these computers in our environment. So they are going to be used then in manufacturing, in logistics, in retail, smart cities, agriculture, smart homes. So monitoring the goods as they are moved around in the logistics chains, monitoring you in a retail store, monitoring the goods in a retail store, and then providing real-time actionable data for the businesses and also for the municipalities and governments, so that processes could be more efficient and the environment would be more pleasant. But 75 billion computers seems to be a whole lot. So the question is, how do we work with these computers, and how can we make them work for our behalf? Taking a look on how we have used computers over the decades, and how we have interacted with the computers. So this is IBM 360. The guy in the middle there, he's interacting with the computer. So he's putting commands into the computer, and then the computer is giving the human feedback. And I would say that this has not really changed. Since the 1960s, we have interacted with the computers almost the same way, and only now this is beginning to change. So the computers have become smaller, and we can have the power of a 360 on our laptop, on our couch, or in our hands in a coffee store. But the way we interact with the computer is still the same. The computer is a slave. We tell it what to do, and then we get the output from the computer to the request that we made. Of course, sometimes things go wrong. Computers don't always behave as we expect, but most of the times, this is how they act, and this is how we expect the computers to act. Now, this kind of mentality or approach is also being applied to the invisible computers in our environment, to the Smartdust. So we have dumb nodes, we have slaves at the edge of the network or in the devices in the field, and then we have intelligence in the cloud. So there's servers in the cloud, and then there's a human giving commands to the servers in the cloud. I would say that this is comparable to the Middle Ages when we compare it to our societies. So in the Middle Ages, you had peasants who then took commands from the noblemen, looked up to them, and then maybe shouted something back from time to time. I hope that everyone in the audience agrees with me that this is not the most efficient way of how to run a country or how to run a society. Instead, what you want to have is you want to have a different structure where you have people who work together, who are intelligent, who are independent, that make up the society, and then you have the local and central governments that give guidelines to these people on how they should behave, what are the rules for behavior, and then these people are able to work autonomously. So this is something we're also trying to do in the computer world. So in the top there on this slide, you see cloud, fog, and mist. What this means is that what we are doing is cloud computing or servers. We are pulling these clouds closer to the ground. When you pull a cloud closer to the ground, you get fog. So hence the term fog computing. So this means that we bring the computation from the servers to the routers and gateways closer to the edge of the network. And when you push the fog even closer to the ground, you get mist. So this means that we bring the computation even closer from the servers to the routers, and then from there to the very edge, to the sensors and actuators, to our refrigerators, to our street lights, to the switches, to the sensors on our body, and so on. And so these devices, these computers at the edge of the network, so the computers surrounding us in our environment, they will work together as we do as a society. And then they take commands, or they take guidelines then from the local and central governments, from the routers and servers, and then they act based on these guidelines, but they're able to act autonomously. One may say that this is a very fancy fantasy again, and one may question: is it really doable? Can we have the computers act autonomously, working together, communicating wirelessly? So this is something actually that has been the focus of my research for over a decade. Is situation awareness of computers. How can the tiny computers embedded in our environment understand what's going on around them and then act accordingly? So the images on this slide, these are images of the situations where humans apply situation awareness. So we subconsciously collect data from the environment all the time using our senses. So we see, we hear, we smell, we taste, and based on these sensations, based on the data we collect, we build an awareness of the situation. We build an understanding of what's going on around us. And then we are able to navigate streets, we're able to drive cars without having accidents. Fighter pilots are able to pilot their planes, and nuclear power station control operators are able to control these nuclear power stations. What one must also understand is that in different situations, different data is relevant for building situation awareness. Again, human does this subconsciously. So, for example, a fighter pilot, when the fighter pilot is in air combat, he's looking at different data versus when the fighter pilot is flying towards a mission area. And subconsciously, then the human looks at different data streams. At one time, he may be looking at the radar screen more, looking at the tactical radar. At the other time, he may be looking at the fuel gauge. So the question is, how can we apply the same kind of mechanisms, the same kind of attention focus also to computers, so that the computers embedded in our environment would be able to focus on the data, on the sensors that are important, and then form an understanding of what is going on in the environment. So once we have taught the computers to be smart, once we have applied these methods in the computers, we will be able to then embed these computers in our environment as invisible devices. And so in our homes, in our cities, we will have tiny computers embedded into our everyday devices, washing machines, light fixtures, windows, curtains, and so on. And these devices will then work with each other, and they will also talk to the big servers in the cloud, from the cloud, and then act accordingly. So, for example, when you're going out in the morning, your house has already retrieved the weather forecast for this day and can recommend you that you should take your umbrella with you because it may be raining where you are going, because the house has also had a look of your calendar and knows where are the places you're going to be on this day. So it is this kind of collaboration between the edge devices, between the invisible devices in our environment and the cloud of how the Smartdust can really bring value to our everyday lives. So this information can be then used, for example, for business and other decisions. So collecting data from the manufacturing hall can help the manufacturing manager to make better decisions, to have more efficient processes in the manufacturing hall, and also predict delays. Same way, when you collect the data in a city, the city government can make decisions on which roads to repair, where should we have more police patrols, and so on, or where should we have better light, so that our environments would be safer and also more convenient to be in. Also, this kind of technology, as it originated from the military, can be then used for military purposes. And this is, again, some work that we have done at Tallinn University of Technology. So this is actually a picture from a test or a demonstration we did in Estonia with the Estonian Armed Forces. So what we had smart computers equipped with sensors detecting the phenomena in the environment. This information is then collected, fused, analyzed, and then provided to a human user, providing the human user with information superiority compared to the opponent, enabling the user to do better decisions and then have an upper hand in a conflict. Exactly the same methods that we use in the civilian applications also. You collect the data, you analyze it, you present it to the user for better decision making. And so nowadays, already what this kind of technology is being used is to control for example, the light temperature in your environment. So these three pictures are taken of exactly the same scene, just the color temperature of the light is different. And also then the human in these different color temperatures is efficient in doing different things. So that when the light is warmer, this makes us sleepier and helps us to fall asleep. When the light is cooler, we are more. Our attention is better, and for example, the learning capability is much better. So actually, what people are doing is in a classroom, they are changing the color temperature of the light based on the activity that is going on. So in the future, we then expect that the environment will likely to the activity going on, the light temperature and the light levels making the environment more convenient for us, and also then making us more efficient. So how do we interact with these invisible computers then? When you ask the question, Alexa, what will be the weather like tomorrow? So is it going to be a girl or a woman that you ask that question? Or is it going to be a machine that you ask that question? Or is it going to be then a machine in your living room that relays that question to the cloud computer or to the server in the cloud? This is something that we already have today. I mean, Alexa or Amazon Echo is maybe not that popular in Europe, but it is quite popular in the US. So nowadays you can already do that. You can already just ask, standing in your living room, you can ask Alexa, what is the weather going to be today? And Alexa will respond to you. And children are actually already learning to interact with the computer that way. So this is, again, a direct interaction between us and the computer using voice. But as the computers get smarter, as their sensing capabilities get better, the computers can predict the information we need, can predict the questions we have, and proactively respond to these questions, proactively change our environment, proactively provide us the information we need at that given time. So, for example, instead then of fiddling with our handheld computers, the interaction with the computers could occur in a scene like this. So the bus station is smart, is able to understand how many people are in the bus station, what are they anticipating, if there's some unrest going on, call in a police, or then manage the bus routes, manage the intervals of the bus based on the way the people move in that bus station, and also based on what the people do in the bus station. Or, for example, when we walk around the university, we go up or down a stairway. The environment can monitor what we are doing, draw conclusions based on that, and then actually adjust then either the environment or adjust the information that is provided to us. Let's say we are running to a lecture and we are late for that. If the computers know that the lecturer is also late, then they can warn us and we wouldn't have to run. A simple example for that. But then there's also, I mean, these are all very nice scenarios that I've described, and I believe that this will be realized in maybe 5 years. But then there's also the challenges when the smartness stops. So, for example, when the building decides that we should not get in right now, or this is not the person that should be allowed in that building, what do we do then? Or when the house decides that the heating the global warming is too severe, and we should conserve the environment. I mean, I agree with that, but I wouldn't want to freeze to death because of that. I would still want to have a warm house. So again, as with any technology, there's two sides of the story, and all the people developing these solutions, developing these applications, and the technology components for these applications have to keep that in mind. So how can these proactive systems that act autonomously, anticipate our needs, how can we make them so that they are still safe and still work on our behalf, not against our desire? And how can they understand what is a legitimate intent and what is maybe an illegal intent, and differentiate between these? But I think these are fun challenges to have, and I'm just a technology guy, so I will and my team will continue developing the solutions to do that. And I hope there will be also people who worry about the ethical aspects and the safeness of these systems. So the future is now. I think it's very exciting times for us. Thank you.